Good afternoon, everyone. This is our panel 2, and my name is Prasad Vaidya. I'm at IIHS. I am a senior advisor and also part of the Sustainable Energy Lab at IIHS. So today, our panel here has five papers that we are going to see presentations for. They cover topics that are related to extreme heat, floods, and energy and water consumption increase as a result of various things that happen in the urban environment. I don't need to talk about climate change related issues. I think Aro's covered that adequately in his preamble. So the papers are actually interesting because they come at it from different perspectives. One of the papers is on developing a tool that allows flood evacuation to happen during floods. Another paper is about marginalized communities related to heat adaptation. There's another one that is on biomimicry related to heat adaptation, and a third one on heat adaptation is on how evaporative cooling can be used in outdoor spaces. So those are sort of the topic areas and in the way in which the papers are approaching them. And then we have a paper, which is the first one that we are going to start with, I believe. Is it? No, it's not. But that paper is on how the semiconductor industry is going to be changing the requirements for energy and water, as well as some of the other urban infrastructure that we're going to be requiring. And India is moving a big way into that. So we'll see that as well as a paper. So it's a sort of a broad variety of topics that we are covering, and also approaches that are broad enough. I am going to be moderating this for those who are online and those who are over here in person very strictly, which means that when you get 12 minutes, you get only 12 minutes. And if you go over, I might stop you. So we'll see about that. This also means that the Q&A is also going to be very tightly moderated, and the way we're going to do this is that each presentation will be done, and then we'll do a 4-minute Q&A session with each presenter rather than doing an entire panel discussion. So that's how we're going to do. The first paper that we're going to have is on the applicability of HES and RAS for geospatial tools for flood evacuation, a case study of the Ganga Basin in Bihar, India. And our first presenter is Neeraj Kumar. So Neeraj, over to you.
Good afternoon to all of you. My name is Neeraj. I'm a water resource engineer and working for a different organization in Bihar. My research and study area is flood evacuation, flood protection, embankment registration, and river training work, etc. So this journey starts from 2013, and now it is 2025. So when I was doing masters, and I selected this topic, and from that time I am continuously working in that. And today it is you can say you can give me the opportunity to present my entire work in front of all the people, all the participants. So I'm going to present some of my work. So the topic of the that presentation is applicability of HECRAS and geospatial tools for flood evacuation, a case study of Ganga Basin, Bihar, India. So HECRAS, I will introduce about the HECRAS. HECRAS is software which is used for the river study, and geospatial tool like some thing like satellite imagery and other geospatial software tools data we use especially for flood evacuation. So in Bihar, we have major 6 river like starting from Gandak, Budi Gandak, then Bagmati, Kamla Balan, Kosi, and Mahananda. These river are one of the who contributes maximum flooding, and these river are being degraded. So I'm going to share another slide. So I want to show the location of the river. This is the entire Bihar in L01. And in the bottom, the Ganga River flows toward west to east. Somewhere you can the broken river is line green is being there. So the Gandak River start from the Nepal, and all these river start from Himalayan foothills. Gandak, Budi Gandak, Bagmati, Kamlavalan, Kosi, and Mahananda. These are the locations. And yeah, so I want to introduce about something what is happening here. So this is the one of the report has been published by Center of Research of Epidemiology of Disasters. It tell that the flood is one of the one rank is the highest in entire world, and the people also affect mostly by the flood, as there are the number of type of disasters like flood, storm, earthquake, extreme temperature, landslide, drought, wildfire, volcano. But the flood is one of the most devastating in nature. So we have to, and another slide, it also tell that the India has the rank one. India has kept in the rank one, where every year, almost every year, we are suffering from flood. And here in the Indian map, we can see that this area, red one, uh, has one of the most probably flood affected areas. So every year we are fighting from flood, restoration, evacuation, and we are in the same place. Every year we have to start from new, from the beginning. Every year the center allocate the huge fund for restoration of river, shifting the people, giving them some grants, some funds, around 6,000 rupees every family. But the situation is same from past couple of decades. So first we have to diagnose why this is happening. Every year, almost every year we are facing the same problem. So we started a study and we found that the siltation in river, which we found, is continuous rising in all major rivers. This is the graph of river Gandak. It from 1972, we can see the area was silt area. Silt area is that like the river is flowing and somewhere the siltation is happening every year. So then we start digitizing this area from 1972 satellite imageries and 72, 73, 74. Every year we digitize the area after the flood. So we found in river Ganga, Gandak, river Budi Gandak, river Bagmati, river Kamlabalan, Kosi, and Mananda. These all rivers are being silted and it is continuously rising. From 1972, we have the satellite image from 1972. So it is continuously rising. There are several reasons for that. So this was one of our finding that the river is being silted and we have to make some strategies for that. And if we are going to make any strategies and for the evacuation of the people, so how we will do it? So uh, here is, I don't know why this happens. There is a place called Gai Ghat. I don't know why this image is not here. Gai Ghat is the main area from all the evacuation strategies or evacuation planning or evacuation things is happening from Patna. And I want to show you the
Neeraj,
first.
you only have
Yes, sir.
5 minutes left.
Okay, sir. Okay. So during the flood, the most trusted networks, that is river, that is railway and road network, become fail. So we have to make a robust plan to evacuate the people using waterways. So we did the study using HECRA software, and we found that during the flood or after the flood, we have the enough water to navigate the boats and vessels in the river. So we did the study, and we found that in every river we have sufficient number of depth. Like in Gandak River, we have 1.6 meter average depth. In Budi Gandak, we have 2 meter something. Bagmati 1.5 meter, 1.9, and Kamla Balan we have 0.75 meter. Same in Mahananda and Mahananda and Kosi. We have the sufficient depth to navigate the boats. So we also make a strategic network, river network, to reach every household in the Bihar where the people are living. So these are the river networks. So the green network say that it is an active channel in which we have water throughout the year, and the yellow one is the block network where we partial water is there, and red channels which is blocked. So we have calculated all the river length and areas, how much we have to work on that. And also where we can make some arrangements for making the jetties. Jetties is something like harbor where we can keep our boats, and something evacuation and strategies we can make, or something like set we can make. So these are the number of counts. So these are the routes where we can, these are route plans, like we have 1 meter depth, 1.5 meter depth, 3 meter depth. So which type of vessels we can use during the evacuation. So we are now recently we have submitted this report to government of Bihar, and we meet the water resource minister and people from different organizations like Mandarega and flood protection department, and we share this report. And every for we make this plan to for entire Bihar, and we have started all the this cleaning activity, dissertation of river, and the people are working on this plan. And recently we got two Jal Prahari Award for this work. One, the director Manrega has got this award for that, and another, the DDC of Muzaffarpur, they have been initiated first for making these channels active during entire season. So this was my research and findings. I cannot explain too well because the time limitation is there. So this was my finding, and this was my strategies for evacuation and the things. That's all from my side. Thank you. You can ask the question.
Thank you, Neeraj. Thanks very much.
Okay.
Fantastic presentation. Great work.
Yes, sir.
Questions from the audience or those who are online? Anyone? Any comments? Maybe I can ask you one question, Neeraj. So
Yes, sir.
this is great modeling work. Anyone? Any comments? Maybe I can ask you one question, Neeraj. So
Yes, sir.
this is great modeling work. I think you've used the GIS and spatial modeling in a really innovative way for work and for an issue that really matters.
Yes,
And from what I understand, you're predicting the water level depth that will be
Yes, sir.
available as a result of flooding, that which then gives you the ability to predict pathways for evacuation,
Yes,
which
sir.
is
Yes, sir.
a great way to use these tools and the information that you have. Are
Yes,
there
sir.
any methods that you know of, or have you used any methods to be able to validate what your predictions of the model are in terms of the water depth?
Yes, sir. We have recently published one paper. So I want to show you the link of that paper. It is here. Yeah, this one. This is activity of HECRAS and 2D GFMS model. Can you see my screen?
No, that's okay. You can just tell us about it.
Yeah.
Don't worry about the screen.
Sir, first what I did, I just run the one-dimensional HECRAS modeling and two-dimensional HECRAS modeling. So it tells us about what will be the depth of the river during the flood and post-flood. So I collect all the informations, and I use the Central Water Commission data set for they publish during the flood time, and also we have some stage recorder during near the ghats. So during the flood time we have, but after the flood we just go to the various sites near the along with the river, and we calibrate our model first, that in that day the water level was that, and what was the height of water.
Okay.
And during the flood, what the information we receive from Central Water Commission, we validate and we calibrate the model, and we also validate it using that same data.
Okay.
And we also have some graded data like GFMS and GLOFAS. They inform the same thing. So we validate the model, we make the reports, and we submit it to the department.
Thank you. Thank you. There's one question that's come in. We'll take one last question on this for you. It's from Chintan. Is the river depth pre-desiltation or post-desiltation?
We found in most of the river that during the monsoon, during the flooding, they have sufficient depth, like 3 meter or 2.5 meter. So at that time we can use these all vessels. After the flooding, we have the low water level, like 1 meter or 1.5 meter. So we can also use that vessels or something like dinghy or something like a trowel. So we can continuously run the that system, this entire system throughout the year. So we can do the planning. We can think about the how we can reach the that place, or we can develop that place after flooding also.
Okay. Thank you. We have one more question that's coming from Shraddha, but Shraddha, I think let's just wait till the end and see if we have additional time, and then we can take your question. So we'll move on to the next presenter now. This is Pranjal and Apurva, who are sitting here with me, and their paper is on exploring the potential for nature-based evaporative cooling solutions for enhancing thermal comfort in urban public spaces. Over to you.
Hi everyone. I've not done this a lot, so I'll be a little nervous. So if I fumble, please don't mind. Thank you so much. This is Apuva, by the way. She's my colleague, and we've worked on the paper together along with architect Manish. So starting with some very generic information, especially for this room, I believe the world is moving towards urbanization at a scale and pace that none of us can, do anything about. I think at this point it's an inevitable change, but already most of the world is urbanized, and even more, I think within like a couple of years, 2/3 of the world will be living in urban areas. And like the global south especially is going to be more affected than the world average. Around 70% of the global south will be urbanized by 2050. And if we talk about India specifically, then again we have data which shows that although not a lot of India is urbanized right now, only 36% as per the ministry, but very soon, again around 2050, it is anticipated that at least 50% of India will be urbanized. So along with urbanization comes a change in lifestyle, and also comes stress. But what we are talking about is heat stress specifically here. So basically the change of lifestyle as well as the change in general materiality of the build structures that are prevalent in most of the urban areas today have given rise to this phenomenon called urban heat stress, which basically means that in urban areas you feel the heat much more than any surrounding countryside or anything like that. In numbers, around the global average is around 3 degrees Celsius, which is a cumulative effect since industrialization to now. And if we, talk about India very specifically again, then it is studied that around 8 to 10 degrees difference in temperature has been observed throughout the day as compared to the surrounding countryside. So this is a prevalent issue, and it might it also has health effects directly, which convert to fatal issues or general illnesses. The major causes for this, of course, first of all, is the lack of green cover, because you need space to habitate this urban population. And then the kind of materials that are popular, which we all have talked about, concrete and glass and stuff like that. So these lead to significantly high rise in the temperatures due to their material properties. And predominantly this urban heat stress manifests in two ways. One is an increase in direct surface temperature, and the other is increase in the ambient air. It's causing a couple of effects. One of them is the cooling paradox, wherein you have your urban surroundings which are hot, due to which you will run air conditioning in your interior spaces, which is again going to further increase the heat stress outside. And Then we also are facing issues in making our open spaces a little more habitable, which are important in urban areas from a socio-ecological and economical perspective. But at present, due to the heat stress in peak summers, these spaces are not very functional, or it's very uncomfortable to stay in them. And another downside here is you can't even use ACs in open areas. So something does need to be looked at while we are dealing with this. So what we explored was a way to kind of tackle this problem two ways. Number one was kind of trying to minimize the heat retention so that these areas do not retain heat in the first place. And then, of course, was an active way to kind of counter the the increase in temperatures or the increase in thermal discomfort that has been happening in these areas.
So when we are talking about absorbing materials and surfaces, an important part of it is the material properties. Talking about the material properties, the transmission that these materials, the heat transmission that these materials do, is what is the root of the problem here. So going for materials which have low heat transmission and have a higher reflectance will automatically increase our will alleviate the problem a bit, and will reduce the effect of the heat stress that is prevalent. Traditionally, this was not existent. The reason being, we were using materials which were not fancy but very functional. So one of such material is mud or terracotta in the modern context, which has a high reflectance and also high diffusibility, so it does not retain heat. Another solution was to actually bring these spaces to the comfort levels that we require. This can happen through various cooling techniques, one of which that we have explored was evaporative cooling. So if you look at the psychrometric chart, we can actually see the 70% of the comfort strategies are around natural ventilation and evaporative cooling only, given that we are living in a country which is hot and dry. Now, water and water-related cooling activities are effective. So our solution to this was bringing together these two things: the high diffusibility material, that is mud, and a high evaporative cooling technique. For this, we used pots or screens made from terracotta pots, which could effectively bring down the temperature up to 4 degrees. The design innovation. So learning from the nature is the easiest thing to do. Learning resilient techniques from nature, we imitated cactus in its principle of retaining and losing heat to keep itself cool. Simulations show that it can bring down the temperature up to 1.5 degrees, 1.5 times, sorry. The design is very similar to how cacti retains water inside it and then releases it slowly to cool itself. A similar setup that we have used in a residential campus. So we wanted to simulate these results. Here we have the actual heat stress that is being faced in these open areas. And since it's an outdoor condition, we are considering the UTCI model of thermal comfort, wherein we've considered 32 degrees to be the comfort, up till 32 degrees to be the comfort range. Here we have 5,600 hours of the year which are out of the comfort range. Similarly for relative humidity. Now, when we bring our solution, that is cacti, into the picture, we see that there's a 8 to 10 degree reduction in outdoor temperature during the peak summers. And at an average, we can maintain the temperature up to 28 degrees, which is well inside the outdoor comfort range. This is a simulation for the peak summer, wherein we can see a clear 5-degree reduction. Similarly, for wet and dry season, we have simulated it and gotten the results to be much inside the comfort. Conclusively, we have seen that it can bring down 10 to 10.5 degrees of temperature drop at its maximum efficiency, and that can reduce the discomfort up to 48%, almost 50%.
Yeah. So, as part of the thermal comfort model, we also have humidity and ventilation, which was also part of this. So, like for example, you can see the divisions between dry monsoon periods. So, in monsoons, what we're doing is this cacti has fans installed in it, so it can also enhance ventilation. So, we do not need to run water during the monsoon period, which is going to further exacerbate the humidity part. So, we'd rather just run fans, so that will enhance the ventilation in the area, in the open space, and that's the way we are looking at maintaining comfort in the humid region, and in the dry regions we are running a combination of ventilation and evaporative cooling. Just to conclude this, so through this exploration, yeah, thank you. This is hopefully going to be a live project very soon. So we'll be able to get back with live data. But in terms of virtual simulations, what we found was this shows a lot of potential. This is not the sole solution, of course, but it shows a lot of potential in the kind of ways we can approach these problems and these issues, and the kind of solutions that can come up with it. Just the very potential of nature-based solutions or evaporative cooling is enough, and just working a little bit on the design innovation bit of it, I think we can get good results. As is shown in this one. So when we finally concluded the study, we were able to bring down the uncomfortable hours throughout the year to just 11 out of 8760. But of course, the final physical testing is supposed to be done after the project is completed. So that's when we'll know how actually effective it is. Then further to discuss this, we talked about two things. One is, reducing the outdoor thermal comfort, but the other is to also, bring a change in materiality that we use in today's buildings. So a part of that is, talking about our building envelopes, where we can increase or, introduce different materials, like we talked about terracotta and etc. So at our workplace and studio, we work extensively in these kind of materials. So one of the things we have developed is a breathable facade, which is made of terracotta, which is also based on evaporative cooling. And figuring out a few simulations, through simulations, we have figured out that we are able to work on a hybrid model, which mixes mechanical means and passive means together to kind of get a fully comfortable environment with a less energy consumption. And that is one possibility. The other is also, if in case we are able to.
Thank you, Pranjal.
Okay, thank you.
Well done, by the way. You completed their entire presentation, and even though you said you were not used to it, your graphics and your presentation was really nice. So let's move on to questions. I will take the online questions first. There's one up there, which is sort of a more practical one. I think the question is, what is the cost of this cactus method that you're doing for outdoor? And I guess then I'll add a question like, what's the area that it serves? And then the other question that is sort of part of this is, what's the longevity of these solutions?
Okay, understood. So at present, this cactus solution is like the one we showed in the photos, is installed at the Ahmedabad airport. And there are like right now it's serving organizations. So the costing is as per that. Recently, we also figured out a way to we figured out a iteration in this wherein we made a cage outside and we filled it in with terracotta waste. So that is a much more toned down or better version of this in terms of costing and all that. Then the next one was the longevity, right?
Yeah.
So in terms of longevity, it is a pretty long-lasting structure. We are developing right now. So it has a metal frame and a terracotta skin on it. So that metal frame is made in SS entirely. So in terms of longevity, you have good metal fabrication structure, and terracotta, although very, very, very long-lasting, like you have historical remains that are made in terracotta as it is, but it is a brittle material. So, but we have made it in a way that it's easily replaceable if any module kind of breaks down. So, in terms of longevity, I would say 5 to 7 years without, blinking an eye. But for its terracotta, so in case something happens to it on purpose, then we can easily replace the different modules that are there.
Thank you. I think there was one question here, and then we'll go to you. About area, like what's the area?
Okay, sure, yeah.
Yes.
So the simulations that we showed you, they cover an area of around 5 to 7 meters radially around the installation, which is kind of like a seating area there that people are going to move around. So they wanted functionality in that. We are also exploring another installation where the area of effectivity is around 10 meters from this installation, but therein we have broken down the installation into different pockets, and we are using further stronger throw of fans to be able to cater to that area.
Thank you.
The research was very nicely portrayed, but I had a
Thank
couple
you.
of questions.
Yeah.
Like the design which you showed about the cactus wall. So if I'm taking that wall in a warm and humid region,
Yep.
especially not in a bungalow but in a high-rise tower, because
Okay.
nowadays high-rise towers are more considered.
Yep.
So how can I propose such a kind of cactus wall in the elevation on a 13th floor or a 15th floor?
Understood, got it. Is it okay if I switch the slides a bit?
Sure, go ahead. But be quick about answering the question.
With time, change it equally.
Of course, of course. So what we have done is it's not entirely clear in this one. But what we've done is we have developed a facade solution for that, what we call the aeroleaf. So in warm and humid, you do not need water. Mostly you need more ventilation. So what we're doing is we put up a screen, and on the other end, in the space, we put up exhaust fans so you can facilitate cross ventilation. What the screen would do is it'll act as an insulation barrier as well as a shading device so that direct radiation does not enter your home. And it's made in terracotta, so it has some level of fundamental material properties in itself to kind of bring the temperature down. Although we have not experimentally explored that yet, we are doing that at present. So once we have that, we will be able to tell you how exactly effective it will be. But the design has changed in that aspect, based in keeping in mind the wind dynamics and the structural system.
Yeah.
Secondly, whenever we are talking that we are proposing such a wall on a facade, we have seen currently nowadays that people are putting pigeon nets and everything to cut the pigeon shit that is coming and destroying the structure. So how can we control this in that?
So this, we always propose this as a second skin, not your main facade. So right behind this would be a window, or it's not visible here, but if you can see on this corner, you'll see a kind of a window pane. So it's like a second skin. So if I'm talking about this glass pane, it'll be right outside this after a feet or so. So that way you can control whatever is coming in if you don't want the wind or air.
Is correct.
Yeah.
Asking that if I'm putting that cactus wall outside,
Yeah.
so pigeons will come inside if there is a cavity. If I'm putting 2 cups and I'm creating the design.
Yeah. In that
Ranjan,
case,
I'm requesting that this discussion, which is about a different solution,
understood.
why don't you take his outside and take it out offline?
Done.
There is one more question that has come online that I'd like you to briefly answer, and then we can move on to the next presentation. So thanking you for the insightful presentation. This person is wondering, Shraddha is wondering about the feasibility of high albedo materials considering high reflectivity and how that could adversely impact the microclimate of that area.
Why you want to take that up?
I think there are 2 aspects to this. One, the high reflectance is within a range where it does not reflect the ultraviolet or the highly heat carrying waves. it reflects that part of the sunlight which is not visible to us. So the microclimate does not get affected by and large. Another thing is it also has high diffusibility. So when I'm talking about high diffusibility, I'm not talking about how air conditioners release heat in the atmosphere, but how this heat release is a slow process through convective transfer.
Okay. Thank you. Thank you for answering a question that was not related to your technology. Okay, let's move on to the next presentation. So this is a case study of Ahmedabad by Ninad Shroff on investigating biomimicry-based architectural design solutions, again to combat extreme heat and decrease space cooling load in hot and dry regions. Over to you, Ninad.
Yeah, good afternoon, everyone. So this research was done as part of the directed research project in my Bachelor of Architecture degree at Sushant University. It was guided by Professor Urvi Desai, and I would like to thank her as well as IIHS for having me here today. So the research addresses the problems of extreme heat and the growing urban heat island effect in Indian cities, and it investigates biomimicry-based design principles that can help improve the thermal efficiency of buildings in high temperatures. Biomimicry is the emulation of strategies seen in the living world as a basis for design. The applicability of these biomimicry principles is assessed with respect to commercial buildings in Ahmedabad, while the research also evolved as a critique of biomimicry itself. For this presentation, I'll be focusing on the relevant strategies to combat extreme heat. So Ahmedabad, like cities across the world, is grappling with problems of global warming and climate change. Ahmedabad has summer temperatures exceeding 42 degrees, and as a series of land surface temperature charts show, the temperatures are only getting higher over the years. And this is also exacerbated by the urban heat island effect. Higher urban temperatures are associated with increased energy use for cooling buildings, changes to natural ecosystems, and enhanced heat stress on living beings. Ahmedabad has rapidly urbanized over the last few decades, and urban sprawl and loss of natural land cover has intensified the urban heat island effect in the city. There's an urgent need to find innovative solutions to make the built environment more resilient to extreme climatic conditions. So after the devastating 2010 heat wave in Ahmedabad that resulted in over 1,000 heat-related deaths, the municipal corporation, along with NRDC, prepared India's first heat action plan. And this includes a cool roofs program, which is effective in low-rise buildings to prevent excessive heat gain. However, such roof-based strategies are not effective in preventing excessive heat gain in multi-story buildings, and there's a need to better equip high rises to maintain indoor thermal comfort under extremely high temperatures. So most households and businesses use air conditioning as a typical form of adaptation to extreme heat. And India is projected to have one of the largest air conditioner stocks in the world by 2050. So like the previous presenters also explained, the waste heat from air conditioning systems also contributes to the urban heat island effect, and it can improve local air temperature by as much as 2 degrees Celsius. Air conditioning systems are also energy intensive, and hence improving the thermal efficiency of the building would be an effective strategy to maintain indoor thermal comfort and reduce the need for air conditioning, hence decreasing energy consumption and also mitigating the urban heat island effect. So much of the country's demand for air conditioning is by commercial buildings, which are offices, shopping complexes, restaurants, etc. In a study, it was found that that offices contribute the most anthropogenic heat emissions compared to other building types. So Ahmedabad has experienced a massive growth and urban sprawl in the last few decades, and much of this growth is driven by mixed use and commercial high-rise development. In 2022, Ahmedabad saw the maximum increase in fresh supply of office space among the 9 major Indian cities. Most of the new development is steel, glass, and concrete high rises, which are not suitable in the hot and dry climate of the region. And hence, these buildings have to be air conditioned throughout the year and through most of the day. So for my research, I conducted a study of 15 recently built commercial buildings in the city of Ahmedabad. This was done to determine patterns in the buildings constructed in the city in the last 5 years. It was also found that most of the new construction is happening in the western side of the city along the SG highway and in Bhopal. So the buildings were analyzed considering factors such as floor plate dimensions, heights, organization, location of circulation and services, etc. It was found that due to regular hours of operation and a central control system in most commercial buildings, there are possibilities of centrally controlled building level strategies that can be used to improve thermal efficiency. The study helped derive a typical commercial building on which to assess the applicability of the various principles, which require a specific spatial configuration for their working. Most commercial buildings were found to have a central double loaded corridor and a centrally placed service circulation core, as well as basement levels. So, how can buildings be better equipped to actually combat extreme heat and decrease air conditioning load? While there are several climate responsive strategies that have been used for centuries in buildings, there's a scope to use biomimicry based design strategies to greatly improve thermal efficiency. Biomimicry, like I mentioned previously, it is the emulation of strategies seen in the living world as a basis for design. Nature has perfected systems that adapt to extreme climatic conditions, and it is useful to study such principles and translate them into strategies for the built environment. Biomimicry is the mimicry of an organism's behavior, or an entire ecosystem in terms of its form, material, construction method, process, or function. And there are several ways of translating these nature based principles into design. There's a top down approach as well as a bottom up approach. So, the two primary thermal regulation mechanisms seen in nature are heat gain prevention and heat dissipation. And animals across the world have employed various strategies for the same through form based adaptations as well as behavioral changes. For example, the large volume to surface area ratio seen in camels reduces heat gain, while airflow systems in termite mounds enhance heat dissipation. A growing number of buildings across the world have also been adopting biomimicry based principles to respond to extreme heat. Analyzing these principles and understanding their applicability in the context of Ahmedabad would be useful in guiding how future buildings in the city can be better designed. For this research, I analyzed 6 case study buildings that have used biomimicry. The 6 case studies are a mix of commercial and institutional, but all of them have a centralized control with a day-night working. While the Torrent Center in Ahmedabad is the only building in Ahmedabad, the other buildings are in similar climates but may not be in climates as extreme as that of Ahmedabad. But they all use principles of biomimicry for cooling.
5 minutes.
Yeah.
Yeah.
So the thermoregulation principles in these buildings were analyzed with respect to climate and spatial organization. This matrix gives a sense of the thermoregulation principles used, and several buildings used multiple strategies working together. And the sectional diagrams show the variety of scales of implementation of strategies, as well as simplified air and heat movements seen in the buildings. It is essential to determine which of these principles is actually applicable in the context of Ahmedabad. So, like I mentioned previously, the case study building showed the possibilities of translation of these principles from nature into strategies for thermoregulation, along with the spatial requirements for the working of these strategies. And the study of recently built commercial buildings in Ahmedabad gave an idea of the typical form and layout in the city. So each principle was then assessed based on these different climatic conditions required for its working, and also the comparable forms or layouts of commercial buildings found in the city. The first thermoregulation principle I'll be talking about is convection or stack ventilation. So here, vertical ducts supply cool, fresh air and remove the warmed air from the building. These ducts can be placed centrally as seen in the Torre cube or at the periphery of the building as seen in CH2. And this method is inspired from the air passageway structures seen in termite mounds. And it's a useful strategy given the climate and common building type found in Ahmedabad. The second principle is evaporative cooling, which the previous presenters had also discussed in detail. So here, evaporation of water is used to cool air or surfaces. The two case studies over here, the Torrance Center, which uses a passive down-draught evaporative cooling system, and the CH2 building, which uses shower towers to cool the air supply to lower floors, use this technique at a building level system. And this principle can take different forms as seen here. Similar processes seen in nature could be sweating in humans and animals immersing themselves in water to stay cool. Night purging is the principle when nighttime air circulation is used to drive out heat accumulated during the day and bring in cool air. So the CH2 building has an open floor plan that is ideal for heat to be driven out at night. And according to a study, night purging alone can lead to a decrease of 14% of the cooling load in a building. Ahmedabad has a large diurnal range of temperature throughout the year, and the use of shafts might be required in the typically found commercial buildings since most of them don't have an open floor plan. Earth cooling is when the relatively stable thermal mass of the earth is used to regulate the building's temperature, and this is similar strategy to burrowing animals. And earth air tunnels are also used in the Terry building
2 minutes.
seen here. The underground temperatures are quite moderate in Ahmedabad throughout the year. Buildings can also employ a kinetic facade that is modulated in response to the sun position, and this is inspired from similar movements seen in plants. So, in the case of the CH2 building, which uses louvers, while the Alba towers have a kinetic facade across the entire building. And this is a skin level strategy. The use of thermal mass can also be used to slow down the transfer of heat from outside to the inside. So there's a wide range of design strategies to maintain thermal comfort based on concepts of biomimicry. This research concludes that using various nature-inspired systems of cooling and ventilation are effective to varying degrees in reducing the space cooling load and maintaining indoor thermal comfort in peak summer months in a climate like Ahmedabad. The most effective principles for Ahmedabad with respect to the hot and dry climate and commonly found commercial building typology are evaporative cooling, earth cooling, and night purging. To drastically decrease the need for air conditioning in hot climates, a group of principles and not a single system derived from natural organisms is needed in a building. Adapting building systems to improve thermal efficiency and replicating these strategies across buildings in the city can decrease air conditioning load, thereby reducing overall energy demand and also mitigating the urban heat island effect by decreasing anthropogenic heat emissions. So, how to incentivize the use of biomimicry-based design strategies for thermal efficiency? These are often not employed since knowledge is either lacking among stakeholders or there are not sufficient incentives to utilize them. And these can be incentivized through guidelines or policies such as rating systems or building codes. Also promoting them by saying that they are helping with cost reduction or in image building, as seen in some of the case studies. And finally, this research calls for architects, developers, and governments to be mindful of the effects of the built environment beyond the building site and the intended users, and to be sensitive to local climate and how their interventions affect the larger environment of the city. Thank you.
Thank you, Anand. That was a very clear and very well articulated presentation, and I really liked the way you were very specific about the strategies that were used and how they relate to the biomimicry principles. So, very good presentation. Let's move on to questions. I don't see any online, so we'll move on to the crowd over here. First question coming from here.
And I want to ask how many degrees change would be there? How many degrees would be reduced? Any idea?
Can you be quick about? So I think there's a lot
sure,
of questions.
sure.
So be quick about your answers. We'll
Yeah.
take a lot of questions then.
So this is very specific to the building type and also the strategy that is used. So I cannot give a comment on the exact temperature change.
Because you said in the beginning that you began with an intent to critique biomimicry, and now giving us. I just want to know more about that critique to proposition framework and what happened to the critique.
So the critique is also part of my research, which I chose not to present here because I felt it was a little away from the theme of urban arc. But maybe we can. So I mentioned a point about image building and how many architects have used this concept of biomimicry to promote the building itself. And in some cases, I also felt that biomimicry principles were not used at a performance level, but more at a surface level. And this, in some sense, also relates back to a kind of greenwashing that some architects do. So
Thank
that
you.
was also criticism.
Thank you for that question and thank you for that answer. Here.
Thank you for a very clear presentation. Just to question is all these solutions are for new buildings only, or some of these are all suitable for
Existing retrofit buildings, I guess that's the question.
So my research was limited to looking at new buildings, and I wasn't looking at retrofit strategies.
Okay, we'll take one more question up from the back there.
Great presentation, Ninad. I think you touched upon this towards the end. So my question is, for this to work at scale, there's a role of thermal governance. In your case studies, how did you see the onus on real estate developers to adapt these strategies and incentives for them to make this work at scale?
So I think definitely having rating systems that are more inclined not just to building energy efficiency, but also how the design of the building itself is kind of addressing climate resilience in a broader sense, that would definitely help. And also maybe just through a practical way explaining to developers that using these kind of systems might be a little more expensive in the short term, but when you think of the project in the long term, you are saving a lot on energy by reducing the air conditioning load. So trying to take it in that sense might help convince people that these are strategies which should be used.
Thank you. We had one question from Ruchi. Ruchi, I think Ninad answered this question by saying that the existing buildings were not part of the scope of his research. So thank you, Ninad. So great presentation and good Q&A. Moving on to the next person here. That's an online presentation, correct? Yeah, that is Sustainable Cooling Futures for Marginalized Communities of Pune. Presenters is Namrata Damankar online. Over to you, Namrata. Hi, Namrata, you're still on mute. Yes, here we go.
Hello.
Hi.
Hi, Prasad. Good seeing you. Good afternoon, everyone. I'm architect Namrata Damankar. I'm a faculty at the Department of Environmental Architecture at BNC, an institute based out of Pune. And I will be presenting here a topic on how we looked at marginalized communities and actually looking at sustainable cooling as a part of the community development in the city of Pune. So yes, of course, I think we have already set the context for this entire panel discussion happening so far, that we are experiencing a lot of increase in heat stress all across the country, and Pune is obviously no less. And the kind of communities and the marginalized communities that are actually the most affected is something that we wanted to highlight, and that sort of formed the basis of our presentation and the research work that we are doing. Of course, Pune, as some of you might know, that once was known as the pensioners' paradise, right? It was known for its moderate type of climate. It was known for its very few discomfort hours. We had very good, winters, but all that is obviously changing if in the last decade. And every year we are actually experiencing intense temperatures, or in summers especially, moving up to even 42 and 43 degrees during peak summers. Of course, it was also a city once, because of its moderate temperatures. It didn't have a culture of using air conditioning in buildings, especially. And today we are actually seeing that all across. Air conditioning coming across, and we can actually see that urban sprawl sort of taking place. And in all of this urban sprawl that is actually growing as a city in Pune, we can actually see that it is very evident that more than 35% of the urban population in the city is, living in informal settlements or slums. This we are sort of second after Mumbai, where we actually have a very large population staying in slums and informal settlements. So just again to set the context, when we start looking at how the city has really rapidly grown in terms of the growth of the city, we can actually see that an average of about 7.5% is every decade we are growing in terms of the urban population or the city limits actually growing, right? Pune again once was a radial sort of very core city. We were a small city, but if you see over the years since 1990, the kind of development we have had, we have our city limits growing. And what that is actually leading to is actually urban development, urban sprawls coming up all across, and that directly then has an impact on the kind of urban heat island that we are producing with all the development that is happening. So again, just some Landsat surface temperatures, showing over the last decade, right from 2013, you can actually see that what we have witnessed when we studied these were actually that there were no changes in terms of the key differences in the temperature rise, because there has been intense temperature rise. But what you can actually see is that there is significant variations across the geography. Right. So you can actually see that the hotspots are actually cropping up, not in the center part of the city, but it's more towards where the newer development is happening. So again, it's very, very evident that with urbanization, what is actually happening is that they're actually developing these hotspots now across the city. Now, coming to the context with respect to the study that we did, then we identified the area of our context where we looked at informal settlements. And of course, we had to identify 2 or 3 settlements, which we then picked up. Here you can see for our particular study, we picked up 2 settlements which had diverse sort of context, had diverse settings in terms of, so if you see the first image on the left, the Kishkinda Nagar, it actually had a setup of being situated on a hillock. So it was, like I said, that was the setting that this particular settlement had. Whereas if you see the Shinde Vasti, which is on your right, actually had a context of being located or situated next to a nala or a water stream that was sort of there. So 2 very diverse sort of context and settings, but both of them experiencing the same problems of extreme heat stress, and that is because of the kind of settlements that was seen here. As part of this project, now coming to the methodology that was actually used to develop this entire framework was on the basis of a concept or methodology called as co-production, where we actually looked at, so the process of co-production actually looks at how you can involve people from different backgrounds, different expertise, people having different expertise, knowledge, to actually come together and co-create or co-produce something that can actually make a difference, right? So actually, there is no hierarchy here. What we are actually trying to break or move from the traditional approach of, moving towards removing the hierarchy barriers that we have, actually giving importance to all stakeholders equally into this method of co-production. So for this particular project, like you can see, we actually had a focus group discussions and interviews with all societal actors, as we call them, right from civil society organizations to citizens to actually people who were experiencing those issues in those slums, slum dwellers, and then also looking at architects and practitioners who could actually face that problem. In terms of the methodology, we actually then sort of had 2 very focused group discussions that we conducted in the communities itself, where we had a set of questions, as you can see on the screen, where we first tried to ask the slum dwellers that what are the experiences they are facing with respect to the the heat stress that is increasing. Is there a particular pattern that they have seen across seasons, across years? Is there any spatial difference that they are seeing? Is there a particular space that they are using differently or with respect to another, right? So these were the first experiences that we actually wanted to hear from those people, followed by, certain strategies that they were actually implementing or, using at this point of time to actually ensure the thermal comfort. And then
Namrata,
further,
yeah.
what we also wanted to understand was that
Namrata,
what were the yes.
just 4.5 minutes left.
Yes, yes, yes. So also in terms of then we had to ask them in terms of what are the aspirations that they sort of have in terms of trying to make themselves comfortable in the future. What is it that they would like to see? So yes, again, because they were people who we were talking to and not sort of experts in terms of we wanted to actually create this entire approach where they would be very comfortable in kind of sharing their experiences. So we came up with this very small sort of innovative focus group discussion where we actually have asked them to sort of stick in small post-its and actually come up with how they were experiencing the particular space. So this is just some images of that. Um, of course, like we said, the focus group discussions were conducted in their community itself. And we actually gathered people from the community to share their experiences. Just some of the images, the kind of households that these people were living in ranged right from a tin roof for housing to maybe just the roof being tinned or the entire house being tinned to some of the houses which were actually brick houses. So just some images from the field. Again, the kind of flooring, the kind of development that you can actually see that people have just gone about extending and gone vertical over the years due to the increase in family size and social increase or structure. And then, of course, then in terms of some of the early findings that we had from there is something that we would like to share. That, of course, it is very evident that people over the last who have been staying there for more than 30 plus years have also experienced a lot of change in the heat patterns. People, it was absolutely impossible for them to even sleep during the nights because the entire day the tin roofs have actually heated up their house so much that it becomes impossible for them to sleep over the in the nights. This has obviously affected their physiological, health itself. There are very small enterprises there also that you see that they have actually noted that they have lost, the productivity to actually work. They have lost their businesses. They have, in terms of the business hours that they are managing to work. In terms of the intersectionality, also you can see that definitely women are more affected during the summer months than the male counterpart. We can also see senior citizens who are at home being affected more. Women have to change their cooking hours because they are unable to work in the kitchen with that heat. So, of course, there have been so many issues that we have identified as part of this focus group discussions. And then, of course, there are certain strategies. Typically, what we would see is that over the years, people have actually, taken in cooling, fans or coolers to actually make themselves feel comfortable. But the extent to which this comfort is also very limited. So people are saying that even fans and coolers today are not working with the extreme heat. So then the people are resorting to strategies like taking frequent baths. But again, there is water shortage problem. So one problem sort of leading to another is something that we typically notice. And then, of course, these are, like I said, the strategies and their aspirations. Obviously, if they get the money and the funding, they would want to change their house itself. The tin roofs that they are facing, they feel that an RCC or a brick structure would sort of give them more, adaptability. So that is what they all aspire to have. And of course, so we could actually see that air conditioning was not an aspiration for these people. It was more to do with comfort in sort of having a better quality roof or a structure over their heads. And this is, again, just to conclude that we can actually see that there are certain very specific policy implementations that are actually required, and how slum dwellers also should be made a priority in the cooling interventions that we are looking at as a city. And of course, one of the key findings that we want to sort of take ahead is that we realize that communities are also okay with having shared cooling spaces or community level interventions that actually can support the cooling of these during the extreme heat stress situations. And of course, just to conclude with, we had this entire project was actually a joint project done with the University of Leeds, BNCA. We actually had the civil society organization represented by Basera Foundation. And of course, the co-production methodology was something that we looked at from the Leeds Social Science Institute. So yes, this is an ongoing work, and we hope to sort of scale this to with more sort of focus group discussions and actually having pilot implementations of certain projects.
Thank you.
Thank you.
Thank you, Namrata. So I loved the photo that you showed on co-production where there were two dogs sitting half in the sunlight, half in the shade, just giving
Right.
us an idea of what kind of workshops you were running. Thank you for that. Very interesting work and methodology. Moving over to questions. Any questions from the crowd over here? Yes, we have a question from here. We'll make sure you can hear it, Namrata. So mic is
Yes.
moving over to the person.
Yeah.
Thank you so much for a wonderful work presentation. Can you elaborate a little bit what the community solutions, what they look like, what do they entail? Thank you.
Did you get that?
Yes, yes. So one of the solutions that, like I mentioned, that we plan to, that came from these people, where that the community, you can actually have these sort of community open spaces that actually can be developed as certain cooling spots where people from their houses during the peak summer times or the peak afternoons can actually come, take some comfort in terms of, say, water mists can actually be provided in those, so there are these sort of decentralized smaller hubs, cooling hubs, where people from their households can actually come and gather together, because that also becomes a space where they can share their daily activities, and that is what people are doing right now. So that is one of the strategies that came across from our focus group discussions. And second was also something that is already ongoing, but it's not really working very well, is in one of the slums that we actually came across, there were actually roof gardens or terrace, green roofs that were actually implemented in one of the houses. And there was actually that significantly dropped the temperatures in the households. But of course, that's an ongoing work done by another NGO there, where they were recording the temperatures and what is the temperature difference that they're getting. So in these kind of solutions can actually sort of be scaled up is something that we are looking forward to in the coming months.
Thank you. Any other questions in the room? Yeah, we have one more question here.
I wonder whether the paint on these galvanized steel roofs, white paint, would have a significant effect, because it seems to, in places like Ahmedabad, single-storied structures.
Right. Unfortunately, no. I think there is enough study today to, prove that these white paints or the application of these paints is not really serving the purpose, because what that is ultimately doing is causing a lot of glare and reflection at an urban scale. And the other problem with this white coating or paints is that the maintenance, because every 2 years you have to repaint it. So these were all the solutions that right now have been implemented and they are under testing. But definitely there have been some very initial studies which say that the white paint is not really the best solution for these, and especially the tin roofs, because they will require continuous maintenance.
Great. So, Namrata, I think you and Apurva, who's sitting over here, need to have a conversation afterwards because you have differing views on white paint. We have a question coming in from the online audience. Arka is asking, how do communities realize heat vulnerability? Is it what's felt or it's data driven? How do communities respond to data?
Yes. In fact, there was a second part of this study which I didn't present here, was the quantitative part of this, right? So yes, right now this particular co-production methodology that we have used is completely based on what the people there felt, right? So it was more about their feelings, what they felt, what was it that they were doing. So, but of course, at the same time, in both the one of the communities out of the two, we have actually also done data centric sort of data collection, where we have actually installed data loggers, and so like I said, that was the second part which we have not presented here. So I'm happy to share that offline if anybody wants to know that. We have also seen that there is something that goes hand in hand in both this qualitative and quantitative data.
Is it included in your paper?
No.
Okay.
We only had this qualitative methodology put in here.
Okay. Thank you. Thanks,
Yes.
everyone. Let's give another round of applause. Let's move on. We'll take questions at the end if we have time. Sounds good? Okay, moving on to the next presenter, which is our last paper here. That is Elora Ghosh on from chips to cities, the unseen semiconductor revolution driving South Asia's urban transformation. Over to you, Elora.
Very good warm afternoon to all present here. It's a beautiful amalgamation of think tank of experts here, and I feel very obliged to be presenting my little research done. I'm Elora, and I'll be speaking on the topic for the IIHS annual research conference. My title of the research goes from chips to cities, the unseen semiconductor revolution driving South Asia's urban transformation. So, dear guest, the world today is in the midst of a profound technological transformation, one that is quietly but powerfully reshaping industries and economies alike, the semiconductor revolution. We have been hearing a lot of newses. A lot of reports have been coming up regarding works that a lot of MNCs are working upon. A lot of experts are giving their policies about how to go about with this semiconductor revolution. But how much do we know about it? So, in these tiny chips, the brains behind the modern electronics, are driving innovation at an unprecedented pace. And in South Asia, this revolution is not just confined to gadgets and technology sectors. It is transforming the very essence of our urban landscapes. As cities across the region embrace smart technologies, digital infrastructure, and automation, semiconductors are at the heart of this transformation. So, from driving at the heart of this smart city initiatives to enabling efficient energy systems and enhancing urban mobility, the ripple effects are immense. So, this evolution is reshaping how we live, how we work, and how we interact in urban spaces, and making South Asia a very key player in the global semiconductor narrative. So today we'll dive into how this unseen force is catalyzing urban transformation, creating a new era of intelligent, connected cities across the region. So valued at over $500 billion in 2023 and expected to grow further, projected to reach about some $1 trillion by 2030. This industry is worth all investments. And with the turbulent pandemic that has hit us all very effectively, the demand for these chips as industries ranging from healthcare to logistics rely more heavily on digital solutions. The race for some Southeast Asian countries to get into this industry in the global semiconductor industry is very open and very evolving, even if it is complicated by factors like great power rivalry. So the US and the other Korean heavyweights in the semiconductor supply chain, they have turned to Southeast Asia to hold a flood of new projects, with most going to Singapore, Malaysia, and Vietnam. And India is determined to not lag behind. India has some big ambitions to become a very semiconductor powerhouse as the world's fifth largest economy pushes for self-reliance in manufacturing. Modi has set up certain numerous goals to propel the country's semiconductor sector forward, with the latest and biggest target being to grow the country's electronic sector. India is increasingly viewed as a viable alternative to China for companies. And we also see that certain companies have already started putting out how they can contribute towards this industry along with the government of India. So, but the government also tries to understand what kind of proactive steps that we can take amidst all the backlashes and controversies that one has been hit by. Self-reliant government took initiatives such as the Semicon India program that has been launched at 10 billion to attract investments in design, manufacturing, and display fabrication. India Semiconductor Mission that aims to develop a robust semiconductor and display ecosystem that focuses on R&D, infrastructure, and skill development. But we need to understand how this change of scenario helps us in understanding how this will help us in growing through urban transformations in various cities, how this will help people. So, if you look at the previous map that was showing, we do have 3 setups currently that government is proposing, 2 vary in our Gujarat and 1 being in Assam. So, the boost in domestic semiconductor manufacturing will accelerate the deployment of smart infrastructure in urban areas, ranging from intelligent traffic management and energy efficient buildings that will attract investments, create jobs, and foster ancillary industries, leading to upliftment of cities. Enhanced semiconductor capabilities will enable the rapid expansion of digital infrastructure, improving internet connectivity, data centers, and IoT applications, making cities more connected and efficient. Advanced semiconductors will facilitate the integration of renewable energy solutions and smart grids, leading to greener, more sustainable urban environments, also leading to EVs and autonomous transport systems, reducing congestion and pollution while improving urban mobility. So, but this very great initiatives being put always comes with certain challenges. Despite its potential for urban transformation, not every outcome is quite welcomed by all. So, addressing these challenges, the first one that we will discuss is the infrastructure bottlenecks. So, here, setting up a semiconductor manufacturing unit requires significant infrastructure, including a stable power supply, water supply, reliable transportation networks. Many South Asian cities, particularly in India, face a lot of infrastructural bottlenecks that could hinder the growth. So that is one of the reasons why government is still very skeptical about when, where, and how should this industry be put up to.
Elora,
For
5
example,
minutes left.
the setup of semiconductor industry in Jagi Road in Assam, it just intensified certain debates between the states of Assam and Karnataka. And I happened to read this in one of the reports, which stated that the land of Assam has a lot of incapabilities. Assam has historically been very underdeveloped state in terms of industrial and technological infrastructure. Tata has also invested about 27,000 crores. But amidst all of this, Tata Group and central government acknowledged this risk majorly due to the strategic location. Amidst all the backlashes, government said that Assam has a very strategic location and there is a lot of need of infrastructural growth over there. Jobs needs to be set up over there. But a few months ago, media interaction, it had a debate where Minister of State of IT and VT stated Karnataka, particularly its capital, Bangalore, has
Hello?
long been regarded as the technical
Elora?
hub of it. Yeah.
Yeah, 4 minutes left, okay?
Yeah. Okay. So, with a thriving ecosystem of software, hardware, and semiconductor industries, as we all know, the state has boasted that they have highly skilled workforce, research institutions, robust infrastructure that supports cutting edge technological innovations. So companies like Intel and Texas Instruments have already given significant presence they have their presence in Bangalore, making it a very natural choice for semiconductor investments. But this reflected certain frustration in the Karnataka government that we are being overlooked for the new semiconductor projects, and government is going to certain other cities, some tier 2 cities, to set up such a big industry. Now, the state government has been actively pursuing these investments to further cement its status as a global technology hub, and many industry experts have also voiced their surprise at the semiconductor manufacturing being directed to the states like Assam and Gujarat, which are not traditionally known for the technological prowess. However, Bangalore, despite being technology capital, has witnessed struggles with inadequate water supply and frequent power outages over the past 2 years, as we have all heard about it. We have read news about it. This challenges coming from Assam or from Bangalore, from any part of the country, a lot of the states, a lot of the tier 2 cities still face a lot of water supply issues, a lot of climatic changes issues. So now, what are the factors onto which government should look into is something that should be our primary concern with regard to the need and the necessity of the semiconductor industry, that we are all understanding how much it needs to grow and it be par with other Southeast Asian countries. The second that we know is about the environmental
Elora,
concerns.
2 minutes left.
Yeah.
Yep.
So environmental concerns is something that we understand as well. Again, skilled workforce shortage that we are seeing. We are seeing a skilled workforce that is not that is primarily absent in a lot of the cities and a lot of the states, that faces a lot of backlash because of the change of skilled to unskilled labor that we are facing in India currently. So these are the few bottlenecks, these are the few challenges that we are facing currently, which needs to be addressed. And so these are the reasons why Modi still thinks that semiconductors should come up. I'll quickly just take the way forward. Yeah. So research has already been started. A lot of the work has already been started on growing, but somehow we are not still able to get through as how we can definitely get into this industry and how we can go and have a global integration with the other semiconductor supply chain. And we have started with the work, but there's a way forward. There's a long path that we have to really reach. So what should be done? So what we have to do is basically think about certain sustainable, innovative ways of amalgamating a lot of cities together to make this revolution work well in the country, and to actually bring a lot of policy and governance things that needs to be worked upon. The connection between chips and cities will become even more pronounced as semiconductors will be part of all the urban environments in the country. So by investing a little more into semiconductor industry, a lot of South Asian cities can position themselves for a very defined innovation, sustainability, and economic prosperity.
Thank you, Elora. Yeah. So we'll take questions now. On people who are online, please put your question in the Q&A box. And people who are in the room over here, any questions? We have one question. Please pass the mic.
Hello. Regarding the diversification of industries to tier 2 cities from cities like Bengaluru, I think it is a good option to diversify so that decentralized development would be there. And moreover, regarding the skilled labor, most of the skilled labor required for this kind of like polytechnic trained persons will be available in tier 1 tier 2 cities more than tier 1 cities. This kind of development is actually appreciable than to concentrate on already urban sprawl areas like Bengaluru. This is just want to add this.
Okay. So that was not really a question or a comment over there. Great. Thank you very much. Anybody else? We have one question in the back.
You spoke a lot about infrastructural challenges. Could you maybe throw some light on raw material procurement challenges that India faces also? That's also a little, that's like the big challenge.
Yeah. So with regard to the raw materials, all of this while we have been procuring materials from the other South Asian countries. And even now, the topic that I'm discussing about is majorly about the investments that is required with regard to raw materials and labor, skilled labor that we need to really work upon. The raw material is definitely a very big challenge, but the government is working on it, and they are trying to amalgamate other South Asian countries to, at least in the initial few years, they can help the government to procure certain raw materials, and then when we become self-reliant, we can definitely grow in the raw material sector, and we can also produce our own raw materials over the few years. That is the challenge that we are facing, because raw materials does require water availability. And like I said, a lot of the cities, if Sir said about Bangalore, Bangalore does face a lot of water shortages, and same goes for other cities. Like I said about Assam, it has a lot of water shortage issues. So that is something that is producing a lot of hindrance to procure any kind of raw material as of now. So that is how we come to this topic, that before we jump onto this kind of a revolution, a lot of things needs to be worked upon.
Thank you. All right, I think we're out of time. Let's have another round of applause for all the participants here.